Hello guys, welcome to another class. And in the last class, we talked about work, energy, and power. When we explained that work is done whenever a force moves a body along a distance. And we said that when work is inclined, it is given by F times distance cos theta, right? Where theta is the angle of inclination, and when it's not inclined, is F times distance. We said about power and energy, but right now we are going to be talking about an interesting topic, which is called machine. What is a machine? We already know that work is made easier by using machine, right? And we are going to be seeing some simple principle behind this. So a machine, are we getting it now? A machine is a device that makes work easier. Now, how this works is that it enables a force at a point, which means it allows some input energy, so it enables a force at a point. Are we getting it now? We want a force at a point. This is the point to overcome a load. The force will overcome a load at another point, right? To overcome a load at another point. And this is the output, right? So this is the output. So it overcomes a load. So there is a form of point between this place and this place. So it's for like a pivot. But we are going to be explaining those principles later. So all you should understand is that a machine is a device that enables a force to overcome a load, that enables a force at a point to overcome a load at another point. Hence, it makes the world easier. Now, you should understand some characteristics and some facts about machines. Number one, machines are effort multipliers. I'm getting it? They are force multipliers because you discover that what you cannot literally click with your hand, but using a machine, it becomes easier to do it, which means that your effort that was not supposed to lift that load has been multiplied by a factor. So a machine is an effort multiplier or a force multiplier. You should understand that it multiplies your force, right? So another thing is that a machines are speed multipliers. They multiply your speed, right? Machines are speed multiplier. Number three is machines are direction changers. Machines are what? Direction changers. Because of time, I would have explained this. But let me see what I can do here. If I take, are we getting it? If I take a plier like this to cut a wire, and this is a wire, right? This is a wire. Now, note that for this plier to work, there's a pivot here. There's a pivot here. Now, if I apply my force to this point, and if I trace this leg to this side, what will happen? When the force is coming down, this side is going up, right? This side is going up. And if I apply another force here, and I trace it to this side, when the force is going up, this side is coming what? Down. So machines are direction changers, right? Because for this place now to act as a machine, it changes the direction of your force. All right, now examples of machines are levers, pulleys, inclined plane. We are going to be talking about this later. So first of all, what we'll be defining some terms that are important in calculations of these machines. And then these terms I want to list now. The number one is called mechanical advantage. Mechanical advantage. Mechanical advantage. Mechanical advantage, are we getting it now? Tells you the advantage of the machine. It tells you how the machine has been able to multiply your force to do what you cannot do. For example, I lifted a load of 50 Newton. Are we getting it now? 50 Newton by using a force of 10 Newton. which means without me using this machine, I wouldn't have been able to lift this load. But me using the machine has been what? Able to multiply my effort by what? 5. So 5 times 10 becomes what? 50. So this means that to get the mechanical advantage, MA, to get the mechanical advantage, are we getting it now? Which means that MA, the mechanical advantage, is equal to the load. Are we getting it now? The load all over effort. Right? So mechanical advantage is the ratio of the loads over effort, because when you divide the load by the effort, you get how much factor the machine has been able to multiply what you've done. For example, let's say that the mechanical advantage of a machine is 5. If we say that the mechanical advantage of a machine is 5, it means that the machine has been able to multiply your force by what? 5. So for example, if I'm about to do some kind of work, are we getting it? That requires high force. Then I have a machine of mechanical advantage 10 and a machine of mechanical advantage 3. Which one will I choose? I will choose 10. Why? Because machine of mechanical advantage 10 will multiply any force I apply to it by 10 times. So that will be easier. Alright. So the next one we go here is called velocity ratio. Velocity ratio of the machine. So note the first formula down. Mechanical advantage is the ratio of force, the ratio of load. Mechanical advantage, MA. Let me write them up here. MA is equal to what? L over E. And you know that both the load and the effort are both forces. The next one here is called velocity ratio. Velocity ratio. Velocity ratio. Now, what is velocity ratio? Well, velocity ratio is the ratio of the distance moved by the effort to the distance moved by the load in the same time. So we can say that velocity ratio, VR, is the ratio of the distance. Are we getting it now? The distance moved by effort. Write this formula down. It's very important. All over distance moved by the load. Distance moved by load. Right? So this is mechanical advantage. Distance moved by effort over the distance moved by the load. And you may be asked, and you may wonder, it is velocity ratio, right? Why is time not appearing here? Because velocity have to do with distance over time. You should understand that since it happened in the same time, distance over time of the effort over distance over time of the load, so both of them have the same time. What will happen is that the time will cancel out, right? So there will not be time showing in this equation. All we only have is the distance moved by the effort over the distance moved by the load. Let me use a pictorial explanation to explain this. For example, if I have a lever here and I applied, there's a pivot, right? And I apply a force here to lift a rock. So when I push this rod down, it started going up. The distance from here to here, are we getting it now? Is the distance moved by the effort. While the distance from this place to this place is the distance moved by the load, because the load is, there's a demarcation between these points. So here, distance moved by effort or distance moved by the load. Alright, so we have been able to derive two formulas. The next one we talk about here now is called efficiency. What is efficiency? Efficiency, by this symbol, is given by work. Are we getting it now? The ratio of work done by the load, work done by load, all over the work done, by effort. So we say efficiency is work done by load, all over work done by effort, over 100 times 100, right? Because it is measured in percentage. Also, efficiency can be defined as work output, all over what? Work input, over work input, right? So if you know this formula, you can be able to remember the first formula. Why? Because work output, the load is what is coming out, right? Is the load is the result. You are trying to leave the load. Why? The effort is what you are putting into the machine. Why the movement of the load is the result, that is the output. So work output is related to work done by the load. Then work input is related to what? Work done by effort. So make sure you note those two formulas down, because they are very, very important in the subject of machines. Alright, so another formula here you should understand in machine. When we talk about work done by the load, when we talk about work done by load, we know from work energy and power, are we getting it now? We know that from work energy and power, that work is equal to force times what? Distance moved, right? So, which means that work done by the load will be equal to what? Force, the force of the load. And what is the force of the load? Is the load, because the load itself is a force, right? So that's load. Now we still use this times multiplied by distance moved by load. Right? Then work done by effort will also become effort times distance moved by effort, right? So if that is true, we can also write that efficiency, so we can also write here that efficiency is equal to load times distance moved by load all over effort times the distance moved and distance moved by effort, right? So we now have three formulas we have derived from machine, but just understand one. From there you can be able to get the rest. Now you should remember that from now everything here is what? Multiplied by 100. So here will be times, everything here is multiplied by 100. So distance Load times distance moved by load, effort times distance moved by effort, times everything times what? 100. Alright, so if this is true, if we bring out, I want to derive something, and this is called the relationship between velocity ratio and mechanical advantage. If we bring out this side of this equation, what is left here becomes what? Load over effort. Is that true? Is that true? And we know that mechanical advantage is what? Load over effort. Is that true? So that means everything here can be replaced with MA. I'm not wrong if I take my duster or my eraser and clean everything here, and I clean everything in this cycle and replace it with what? With MA. So everything here becomes what? MA. Right? Now here we have distance moved by load all over distance. Okay, multiply. Right. We have distance moved by load. Are we getting it now? All over distance moved by effort. We should know, but you remember that velocity ratio is distance moved by effort over distance moved by load. But here we have distance moved by load over distance moved by effort, which means that when we change this, when we turn it upside down, it will become what? The formula for velocity ratio, right? Which means that if I cycle this place now and I turn it upside down, how do I turn it upside down? If I bring this side to the numerator and bring this one to the denominator, right? And distance moved by the effort is at the top and distance moved by load is at the downside, it becomes what? Velocity ratio. So all I have to do to make this side velocity ratio is to invert it. And we know that to invert something is to what? In mathematics, is to make that thing over, is to make 1 over that thing you want to invert. So which means that this place is the same thing as the inverse of what? Velocity ratio. So this is the same thing as 1 over V arrow. And how is it the inverse? Because when we turn it upside down, it becomes velocity ratio, right? So it's now the inverse of velocity ratio. Hope you get this please clearly. And if you don't get it, no problem. You can comment it on the section below. I will also do a video and explain it so that it will be more clearer. So I can clean up this side, but make sure you still remember that formula, jot it down. I'm trying to derive on that formula and replace. Are we getting it now? And replace this part with what? 1 over V arrow. So that efficiency will now be equal to MA. MA times 1 is the same thing as what? MA, right? Then we have V arrow here times what? 100. So the relationship between efficiency and velocity ratio and mechanical advantage is efficiency is equal to what? Mechanical advantage over velocity ratio times 100. An easy way to remember this is to remember the name marvelous. So when you know marvelous, you say efficiency. Efficiency is equal to marvelous. Why? Because MA stands for the mar, then V arrow. So you just remember that name, you can be able to easily to memorize this formula. Thank you for watching. But before we go, remember that no machine is 100% efficient. No machine is 100% efficient. Why? Because the efficiency of a machine depends. Are we getting it now? The efficiency of a machine is reduced by what? Friction. The efficiency of a machine is reduced by friction. So because of friction, the efficiency of a machine is less than 100% or is less than what? 1. Okay. Thank you very much. God bless you. In the next class, we'll solve some problems, and after that, we'll explain some type of machines that we'll come across.